Hey everybody, Mr. C here, and I'd like to go ahead and explain a couple of the properties that are present in the table here. I'd like to answer the why is it that we, say have an absolute value of an expression, say less than a number. Why in the world does this split up into the and compound inequality? Alright, and I'd actually like to start with that one right here. To help illustrate why it is the way it is, I'd like to call on the example the absolute value of x is less than 3. Now I'm going to argue this result from a graph standpoint, and by that I mean I'm going to go ahead and draw a number line here, and at the very center of this number line I'm going to put the number 0. So it all goes back to what the absolute value does for us. The absolute value tells us a number's distance away from 0. So when we're looking at something like the absolute value of x is less than 3, we're trying to figure out values of x that have a distance away from 0 that are less than 3 units. Alright, so what might also be helpful to put on this number line is positive 3, but also negative 3. And one reason why that is because when we find the absolute value of a number and say it comes out to be something like 10, there are two values that would have an absolute value of 10. Positive 10 and negative 10. Anyway, going back to the number line, I'd like to shade answers for x that make this work, or values of x that would satisfy this absolute value inequality. Alright, can you think of a number that would have a distance away from 0 that's less than 3 units? Lots of possible answers exist for that. Something like positive 1 would work. Positive 1 has a distance away from 0 that's less than 3. In fact, any value that's from 0 to positive 3, not including the 3, so I'll put a parenthesis on that, would have a distance away from 0 that's less than 3 units. But we can also include the values that are between negative 3 and 0 as answers for this absolute value inequality. Because numbers such as negative 2 or negative 1, those would have a distance away from 0 that are also less than 3 units. So notice I'm not including the 3 or the negative 3. And one major reason is because we don't have the bar here. So we're looking for values of x that are strictly less than 3 units away from 0 on the number line. But here's where I'm going to make the connection between the absolute value inequality and why it splits up into the and compound inequality. All of our answers for x are part of this shaded region, meaning that an answer to this absolute value inequality is going to be an answer so long as it's between negative 3 and positive 3. So negative 3 needs to be less than the value of x that we choose as an answer, but also the value of x that we choose as an answer needs to be less than 3 as well. So with that logic in place, here's how we would express our answer to the absolute value inequality, and you'll notice it's in the format of a and compound inequality. Alright, so x has to satisfy two conditions at the same time. It needs to be greater than negative 3, but also less than positive 3. Alright, and this is one reason why, actually the primary reason why, when we work with an absolute value inequality involving less than, it breaks up into the and compound inequality. And this actually generalizes to any expression that's inside the absolute value. So we'll look at those examples in class. But for now, I hope you found this explanation helpful. As always, let me know if you have any questions. Otherwise, thanks for watching.